the tasks to complete for U4L3. You can find those under assignments or in the weekly calendar. Today's date is January 8th. We'll start off with our usual kind of pair and share. The question for today, I'm going to throw in the chat right now, is what sport would you compete in if you were in the Olympics? Now, this could be anything. This doesn't have to be something you already know how to play. It could be something completely different. But if you were going to be an Olympic athlete, what sport would you want it to be in? And I will tell you, the Olympics offer pretty much every sport. Between the Winter and Summer Olympics, they offer every sport you can think of. They literally recently approved breakdancing as a Olympic competitive sport. So it's whatever you can think of. Think about that for 20 seconds. And don't forget to check in with and say hi to the person you're in the room with too. We'll come back together in 2 minutes. Rooms are open. And everybody, next on the tasks to complete list is homework check. It's looking really good. All you had to do was make sure you had completed the 2 classwork assignments we did. And then there was the reading on the circulatory system. I'm seeing 13 attempts. Looks like everyone's getting 100% on all the questions. So hopefully we're feeling good there. Big take home for this was that your circulatory system was all about transport, moving things around and providing nutrients and getting rid of waste. That's kind of the big thing. Any big questions or comments on the homework? Feeling good? All right, before we move into that, I did want to wrap up our discussion of climate change. I didn't quite get through the slides that I wanted to get through, so bear with me. I've got a little personal story to share with that too. Oops, sorry, I gotta share to my iPad. Okay. Okay, what's going on? Whew, all right, that took long enough. Everyone, can I just get verbal confirmation? Everyone's seeing like a red and blue graph in front of them?
Yeah.
All right. I think this is where we left off. So this is, I think, really interesting. And this is where you're still seeing actually quite a bit of debate sometimes within and outside the scientific community. But this graph is showing you the carbon dioxide atmospheric levels over time. And that's in blue. And in red is the temperature, average global temperature. And so here you can see concentration of carbon dioxide is graphed on that side and temperature on this side. Now you can see they've adjusted the scales to really show how these two overlap. You can clearly see that as CO2 levels rose and fell within the atmosphere, so did global average temperatures. The only break in this pattern is right here, because we are now currently all the way up here at 400 parts per million of carbon dioxide currently. So what's temperature going to do? Is temperature also going to jump that high? Because if that's what happens, then things are going to get pretty toasty on our planet, and we're going to see some pretty huge and extreme weather changes and patterns, which I would argue we are starting to see already. However, there are a lot of people who doubt this. Specifically, they say that this is correlation, not necessarily causation. In other words, that these two things seem to be happening together, but we can't necessarily prove that one is causing the other. Here's kind of a silly example of this. So correlation versus causation. So did you know that if you take US spending on science, graphed on this side in billions of dollars, and suicides by hanging over here by the hundreds, look at that correlation. So clearly, the more money we spend on science, the more people hang themselves. Very clear correlation there. Now, I would hope that it's pretty clear that these two things really shouldn't have anything to do with each other, yet you have this very high correlation. That's just by chance. However, I would argue that in terms of climate change, we have quite a bit of evidence to back up the idea that carbon dioxide and methane and other chemicals are capturing and re-releasing solar radiation within our atmosphere, and that we are drastically increasing the amounts of these gases present, which is why we are seeing these changes in temperature on our planet that are happening at a much faster rate than they naturally would. And especially in the northern regions, right? This is where the ice caps are melting, the permafrost is melting. We're starting to see some ecological effects of this as well. So you all took a little personal reflection and look at your own contribution to this with your personal carbon footprint. And again, we emphasized in our previous class, transportation was by far the highest for everybody across the board. Not surprising due to use of planes and cars. And personal purchases was by far the lowest. We read that CNN article about how you could reduce your carbon footprint. Turns out there's a bunch of goofy things you could do, like making sure you recycle your refrigerator properly if you ever get rid of it. But there's other things you can do too, right? Even things like recycling help, going vegetarian for a little while, eating a plant-based diet. When you do decide to buy a car, buy a more energy efficient car or a hybrid car or an electric car. Those are becoming more and more available and affordable now. The big one is to have one fewer child. That's definitely not something a lot of people are willing to do or consider, but that would have the biggest carbon savings. In terms of the refrigerator thing, again, that really surprised me. So it turns out refrigerators and air conditioners used to be made with these chemicals. They're called chlorofluorocarbons and hydrochlorofluorocarbons. These are really bad for the ozone layer, right? So these are what punched the hole in the ozone. They got banned in 1987. So these are no longer used. But it's not like we stopped using fridges or air conditioners. We just changed the chemical. So now what's used is called hydrofluorocarbons. Notice there's no chloro anymore. Um, these aren't affecting the ozone layer, but they are 10 times more potent at capturing solar radiation than carbon dioxide is, right? So they're really good at capturing that sunlight energy and then re-releasing it. And so getting these into the atmosphere is not good for global warming or trying to reduce it. So what the CNN article was getting at was that we can't have this in dumps, right? Because if refrigerators are dumped and those hydrofluorocarbons are seeped into the atmosphere, they're going to trap a lot more solar radiation than things like carbon dioxide do. So we just need to make sure we're disposing of these chemicals properly or recycling them. Now, I just want to take a quick moment to talk about my experience in the Peace Corps. This was probably the period in my life where I had the lowest possible carbon footprint ever, and I'll explain why. So, if you haven't heard of Peace Corps, it's a volunteer program through the government. You go overseas for 2 years and work in either education, agriculture, or small business. I was an education volunteer, worked in a rural village school. I spent 3 years in a country called the Gambia, which is right here, kind of in the back end of Africa, in West Africa. And I was located right there, about as far up country as you can get. Even Gambians consider that the middle of nowhere. I was a science teacher in a village school, and I lived with a local family. So here was the hut that I lived in for 3 years. Notice there's no power lines, no electricity, no running water, so it wasn't contributing to carbon impacts in that way at all. It was pretty simple. My only form of electricity was a solar panel that I bought and put on my roof, and I had a wire that went down inside, and I had a little car battery in there that would recharge using the solar panel, and I could charge a tiny cell phone I had, and I had an iPod for listening to music. That was it for my electrical devices. There were no methane stoves or anything like that, so no gases. Everything was just wood that you burned between rocks. This is a friend of mine that I was in training with together. Drinking water wasn't pumped to the house. There's no hydroelectric dams or anything like that. They just had these wells that they dug and then capped off with these pumps. You had to like whale up and down on this little crank here and slowly fill up these containers and haul them back to your living space. These were refrigerators. So these are clay pots right here. And you would fill them with water, and the water would soak out. So essentially, these pots would sweat. And if you guys remember, we learned about evaporative cooling, right? So water is evaporating out of the pots, and it cools down the water on the inside. Now, I'm not saying that it was like ice cold water, but it was definitely cooler than the air outside that was around it. So that was kind of nice. But no hydrofluorocarbons here or anything like that impacting the environment. For bathing, I went to an open well. This is not water I would drink. Often, like chickens would fall down in this thing and die. Not the nicest water, but it was good enough to bathe with. So I had to haul that up and down. And in terms of transportation, there were definitely cars and trucks and all that kind of stuff. They called the buses the gele-geles, but they were really unsafe, and I just didn't trust them. And so I went around everywhere on my bicycle. This is the one thing that Peace Corps gave us, was these really nice Trek bikes. So I would load things on the front and the back and on my back just to haul things around. So again, I wasn't using a vehicle at all. So really the only thing for my carbon footprint would have been my flight to Africa and then my flight from Africa 3 years later. Um, Farming was done everywhere, so everything I ate, almost everything, it was locally grown right outside the village. There was rice that was imported from the United Arab Emirates and a few other places, which technically though were also close by. Fruit was all over the place. These are mangoes. Used to love mango season. It's baobab, and this, believe it or not, is a cashew fruit. So if you guys like cashews, the cashew nut, that's the cashew nut right there. It's inside that container. But cashews actually have a fruit. A lot of people know that. It's really, really tart, really acidic, but I like them. And we did a lot of gardening too. So grew a lot of vegetables and stuff that again was all locally grown. So anyway, I'd just like to share that because I think my carbon footprint has never been lower since then. Any questions or comments on that? All right. Well, then, the next thing to do is to review and make sure you're feeling comfortable with the circulatory system. But let's see what you know about the human body. So let's explore some fun facts. On the tasks to complete list, we are now on step number 4, fun facts about the human body. I'd like you to click on the link there. It'll take you to a Google form that has 4 questions. This is anonymous and they're not graded. So just take your best guess on these 4 questions and then we'll come together to review. I'm just going to time for 5 minutes to answer them. 5 minutes to answer the fun facts about the human body Google form. Skeletal system. So assuming equal weights, human bones are 4 times stronger than what? The correct answer is actually concrete, which is crazy to think. Now again, a lot of people react to that and say, wait, when I fall on concrete, my bones break. Concrete doesn't break. But again, that's why I said by weight, right? So if you had an equivalent weight of concrete and tried to build bones out of that, it would be much weaker. Bones are very light and very strong. How much saliva will you produce in your lifetime? It is indeed enough to fill 2 swimming pools. Try not to imagine yourself swimming in a swimming pool of your own saliva. You can eat blank because your stomach acid is strong enough. It is indeed zinc. In fact, you could also eat even things like iron nails, which are all part of our they can actually be digested and implemented, right? You need iron in your blood, you need zinc and things like that. Gold, I don't necessarily know. Maybe. Gold's pretty stable. I think you just poop it out again. How many gallons of blood does the human heart pump? It is indeed 2,000 gallons in a day. Now, that's not saying you have 2,000 gallons of blood. It's just the same volume of blood going around and around all the time. Pretty cool. Questions or comments on that? All right, I got an Ed puzzle for you to work through as review of the circulatory system. It's just me explaining a few things. I think it's a little over 13 minutes long with 5 questions. I'm going to time for 20 minutes, but I'll keep an eye on Ed puzzle. And once it looks like everyone's got it done, we'll come back together to review. So 20 minutes to work on the human circulatory system Ed puzzle. Step number 5 on tasks to complete. And as usual, there is an alternative Google form if you can't get the Ed puzzle to work. Let me know if you need help, if you're not sure what to do. It's because it has metal in it. Hemoglobin, which is the main protein that carries oxygen, has iron, 4 iron molecules for each hemoglobin, and there's hundreds of thousands of hemoglobins in every single blood cell. Pretty crazy to think. Any questions or comments on that? Look like you're feeling good. Okay, I know this can be confusing, and so what I wanted to, the final thing I wanted to do was have you do a drawing. I feel like drawings just help people learn stuff, and I think it's a nice visual summary. I know it doesn't always work for everybody, but it's a nice visual summary of circulation. So on the tasks to complete list, you're going to click on the last one, number 6, summary of circulation. There's a circulatory system summary drawing. Click on that. It'll take you to a little assignment, looks like this. There's instructions you can follow, or you can just look at the example drawing. You can click on that link up there. Here is what you should draw in your notebook or on a blank piece of paper. It would be great if you could use 2 different colors. So if you have access to red and blue, that would be ideal. If you don't, it's okay. I'm not going to mark points off. You could use different colors too. You could use like orange and green. Doesn't matter to me. But having 2 different colors, I think kind of helps make the distinction. So again, I'm going to time for maybe 10 minutes to work on this, get your drawing done, and you can submit it. And then we'll come back together to conclude.